Are the following pair of sets equal? Give reason. First question we are taking, then the solution of first question. Here we have given these two sets. You can write again A is equal to what? 2, 3, and B is a set of all x such that x is a solution of x belongs to x square plus 5x plus 6 is equal to 0 equation. In short, I have written. So we will see that what are the solutions of this equation. We will solve this equation. Finally, we reach to the conclusion that what are the elements of the set P. So we have to solve this one. X square plus 5x plus 6 is equal to 0, and split 5 into two parts, 3 and 2, x square plus 3x plus 2x plus 6 is equal to 0, and x is common, x plus 3, 2 is common, x plus 3, and so finally we get x plus 3 and x plus 2 are the factors, and therefore it will give the value of x as minus 3 and minus 2. So therefore B set will have the element minus 3 and minus 2, or minus 2 and minus 3, minus 2 and minus 3, which are not equal to this one. Therefore they are not equal set. Therefore A and B are not equal set as their elements are different, as their reason, as their elements are different. Okay. But next part of this question is, here we have given the two sets. The second part, A is a set of elements x such that x is a letter of word follow. F O double L O W, follow. Okay. And B is a set of all x, all y. We will take y. Y is a letter of the word. Y is a letter of the word wolf. So WOLF. Okay. And I told you that we cannot write the two elements two times in a set. So if you see this, if you will write it in the tabular form, so this will have the elements F, okay, then O is two times, so we will cut two times, but we'll write one time. Then L two times, we'll write one time, and W. So A will have the elements F, O, L, W. And similarly, this word B will also have F, correct? L is also there, and so we can go this sequence. So F, then O is also there, yes. Then L, okay, L is also there. Then W is also there. So same element. They have same elements. Therefore, they are equal set because exactly same elements. So since we will write the reason, since every element, every element of A, A is in set B. Every element of A is in a B and every element of B is in A. That is, both have exactly same element. And every element of B is in A. Or we can say that is both have exactly same element. Both have exactly same. Both have exactly same elements. Therefore, we can say A set is equal to set B. And set of positive integers greater than 100. Greater than 100 positive integers are many. There are greater than 100, 101, 102, 103, and so on. There is no limit. So it is infinite set. Set of prime numbers less than 99. Prime numbers. Prime numbers less than 99. First prime number is 2. Okay. It will start from 2 and up to less than 99. Before 99, less than 99, 98, 97. I think 97 will be not divisible by any number. No, that's yes. So this is having some finite number of elements, therefore it is finite set. It is a finite set. State which of the following set is finite? Again, finite, infinite. Set of lines which are parallel to the x-axis. Infinite lines we can draw. Set of letters in English alphabet, finite, 26. Set of numbers which are multiple of 5. Yes. Multiple of 5, infinite, correct. Afra, correct. Okay, so like this we can have answers. These are one line answers, so that's why I'm directly doing it. And here also you can see, yes, correct. Finite, infinite, yes, correct. Afra. So set of animals on the earth. Set of animals on the earth. Can you tell me set of elements on the earth?
Infinite.
Yes. So finite set of animals on the earth is finite. Huh? Always remember, is finite, and the number of circles which can be drawn is infinite. We can draw infinite circles by taking one center when many circles. Okay. Similarly, now we have to show that whether they are equal or not. So what we will compare, we will see that whether A is there. Okay, yes, A is there. B is there. Yes, B is there. C is there. C is there, and D is all four elements. It has same number of exactly same elements. Therefore, here A is equal to B. Check here. Yes, 4. 4 is here. 4 is here. 8. 8. 12. 12 is not here. So A is not equal to B. Here A 2, 4, 6, 10, and A is a positive even integer less than 10. Positive even integers start from 2 and 2, then 4, then 6, then 8, then 10, then uh, 10. 10 is also, so they are equal. So A is equal to B. Multiple of 10. 15 is not the multiple of 10. They are not equal. A is not equal to B. Again, we have to, this we have done just now, this question. wolf, follow we have done. From these sets, select equal sets. Now out of these sets, we have to select what are the equal sets. So if you see B and D, B 1, 2, 3, 4, 1, 2, 3, 4. So B is equal to D set, and E set, check E set, and G set. G E is equal to set G. These are two equal sets. So that is all about this exercise, and whatever we studied that is applied here. Subset. Okay. In general, we can say that if there are two sets, let's say that A and B be two sets. Okay. And if every element of if every element of A is an element of B, means every element of A should be in the set B, belongs to B, is an element of B. We can say every element of A belongs to set B. Every element of A belongs to the set B. Then we can say that A is called a subset of B. Then A called the subset of B is called a subset of B. Okay. So every very element, and we write as, or we used to write in mathematically as A is a subset of B. A is a subset of B. We read as A is a subset of B. And in other words, we can say if A is a subset of B, implies that if whenever A belongs to, mathematically we can say whenever A belongs to A, means any element belongs to A, then it must belongs to B, then A must belongs to B. Okay, then we can say A is a subset of B. Okay, so this is mathematically we can say that. It is often we used to use implies, so, or we can write in mathematically, or in better mathematical way, A is a subset of B if X belongs to A, implies that X belongs to B. This is the proper way of writing it mathematically. Okay, so it is read as A is a subset of B. If X is an element of A, then it implies that X is an element of B. If it is not a subset, if A is not a subset of B, we use the symbol. If A is not a subset of B, subset of B, then we write as A is not a subset of B. Okay. One more thing, that if we say that A is a subset of B and B is a subset of A, then A will be equal to B. So for proving A is equal to B, we have if we prove that A is a subset of B and B is a subset of A. So that is only possible when A is equal to B. This means this implies that A is equal to B. And if we use implies that, implies by means both, means vice versa is also true, that if A is equal to B, we can say A is a subset of B and B is a subset of A. If A is a subset of B and B is a subset of A, then we can say that A is equal to B. For example, you can say that subset symbol, just remember this belongs to use for the element belongs to this, and subset symbol, before subset symbol one set should be there. For example, one is a subset of, say for example, we can write from example, one is a subset of 1 2, one is a subset of 1 2, correct? Yeah, they are equal set, correct? Afifa, they are equal. If A is a, I'm telling you that A is a subset, A is equal to B. If we have to prove A is equal to B, we will prove A is a subset of B. Then we will prove B is a subset of A. Then it will prove that A is equal to B. So in some question you will find there we have to prove A is equal to B. We will prove by this way also. That was the direct way that we did. We have checked all the elements directly before. Now, if it is based on some properties, then we will prove it both the way. Then we can say that A is equal to B. This is one of the way of proving A is equal to B. So this is the example. You can write many examples of subset. Like 2 is also belonging, so we can say that 2 is also a subset of 1 2 3. Yes, yes, all equal sets are subsets to each other, and vice versa. Will to correct? That is correct, Afra. Okay, so this is all about the subset. Now, one more thing, we have proper subset and superset. So this, you can see this. This is a subset. One is a subset of 1 to 2 is a subset of 1 to 3, but 2 is less than 2 is not equal to 1 to 3. If they are not equal, subset is not equal to the set, because every set is a subset itself. Every set is a subset of itself. That important result comes from this conclusion. So before that, just you see that what are proper subset. What is proper subset? So in definition, we can say if A is a subset of B and A is not equal to B, means the small set than B. A is a smaller than B. A is not equal to B, means A will have less number of elements as compared to B. Obviously, because we can have same set is a subset of itself. That's why. So A is called, then that set is called the proper subset. A is called a proper is called the proper subset of is called a proper subset of B. Is called the proper subset of B. I think you understood that. One more thing, if A is a subset of B, then for proper subset, and uh, we can write as for proper subset, if A is a proper subset of B, then we used to write actually for proper subset, we are using for proper subset A is a subset of B. Not equal means less than. Okay. So for proper subset, we used to write like this. So if A is a subset of B, so A is called the subset of B, and B is called the superset of A. Okay. For proper subset only, A is a subset of B, and A is a subset of B, you know that. Now B is also said to be the superset of A. B is called, we can say B is called the, B is called superset of A. Is called superset of A. Okay. So if A is a subset, means proper subset of B, then A will be less than B. For example, I'll take one example. Suppose B, I'm taking two sets. Suppose, or we can make the subsets. How many subsets we can make for any set? Let's take one example. I'll make just, suppose we have these elements A, E, I. Okay, three elements I'm taking. So how many subsets I can make? A, this is a subset of this, but it is a proper subset. E is also a subset of this. I is also a subset of this. And I can make with two elements also. A, E is also a subset of this. A, I is also a subset of this. So like this, I will tell you next topic. I will tell you how many subsets we can make from a set. And null set is also always a subset of every set. That will come. Hmm. But what we have, some important results. We found some important results that you should remember. Uh, I will write fast. First is every set is a subset. Every set is a subset is a subset itself. Number first important point. Second point, empty set is a subset of every set. As I told you, empty set phi is a subset of every set. And the third point, number of subsets will come. Total number of proper subsets and total number of subsets. Okay, that we will discuss later on. It will take time.